2017 advanced level logic gate question, right? A switch a temperature sensor B, and a timer C of an air conditioner determine turn on and turn off states of the air conditioner. Turn on and turn off states of the air conditioner as well as the on and off states of the switch, temperature sensor, and the timer are represented by the logical values 1 and 0 respectively. That means if it is on, 1, off, 0. The air conditioner can be turned on or off manually by setting the switch to its on or off states respectively. That means if the switch is set to on, then the air conditioner will get on manually, right? And if the switch is off, the air conditioner can be switched off manually, right? The next one, the temperature sensor detects the temperature in the room. The temperature sensor sets its state as on or off when the detected temperature is respectively higher or lower than a predefined temperature value. The air conditioner is automatically turned on or off when the detected temperature is respectively higher or lower than the predefined temperature value. That means here what they are saying, if the detected temperature is respectively higher than the predefined temperature value, the air conditioner will get automatically turned on, it seems, guys. Maybe sometimes the switch is set to off. The switch is set to off, therefore the air conditioner is manually switched off. But when the temperature sensor detects the temperature is higher than the predefined temperature value, even though the switch is off, the air conditioner will get switched on automatically. That's what they are saying here. Then the timer sets its state as off until it reaches the present time value and sets the state as on once it's reached. The air conditioner is automatically turned off when the timer reaches the present time value. That means what they are saying is the timer sets its state as off until it reaches the present time value and sets the state as on once it reached. So once it reached, it is one on. So in that case, the air conditioner is automatically turned off when the timer reaches the present time value. So if the timer is 1, then the air conditioner will get automatically turned off, right? Maybe sometimes the temperature sensor has detected the respective temperature is higher than the predefined value. But if the timer is 1, then air conditioner is automatically turned off. Okay. So the A, construct a logic circuit using only NOR gates. So you can use only NOR gates to control the air conditioner. Clearly show truth table, Boolean expression, and Boolean algebraic rules used for simplification. Assume that the electricity is always supplied to the air conditioner. So they have given assumption you to assume that the electricity is always supplied to the air conditioner. Right. So let's see how to do this. So let me draw the truth table, and here I'm going to say the air conditioner is Q. Let me say like that, right? Air conditioner Q. So for switch and all those things they have given, switch is A. Suppose if they haven't given, then you must name that. For switch, what you are going to give A, like that. Temperature sensor they have given B. If it is not given, then you must name that. Okay. So here we draw the truth table. So here now, when the C is 1, we know that the air condition is going to be off, right? The air condition is going to be off. One means off. Maybe sometimes the temperature sensor has detected the temperature is higher than the predefined value, right? So sometimes B can be 1, but if C is 1, the air conditioner will automatically turn off, right? Here, 0. Then here, you can see that the switch is off, even though the switch is off, right? Even though the switch is off, the temperature sensor is 1. Therefore, the air conditioner will automatically get turned on, right? Turn on. And here, even though the switch is on, the temperature sensor has detected the temperature as lower than the predefined value. So the air conditioner will get automatically turn off, right? Turn off. Then here also, so here, if you consider in this case, here it will get, so here the switch is also on. At the same time, the air conditioner, the main thing, maybe the switch is on or off, no problem. But here the temperature sensor has detected the respective temperature is higher than the predefined temperature value. Therefore, it's going to be air conditioner will get on, right? Air conditioner will get on. And here 0, right? Off, because they are the temperature sensor has detected the temperature is lower than the predefined temperature value, right? So that's the truth table, right? So you are getting 0, 0, 1, 0, 0, 0, 1, and 0 as the outputs. Then let me use the sum of product. Q equals, so we need to get here, if you consider this case, A bar, then A bar, B, A bar B, A bar B, C bar, A bar dot B dot C bar, right? Then next you need to consider this A dot B dot C bar, B dot C bar. So now you can simplify this. So I'm going to get B dot C bar, B dot C bar. Then when you take B dot C bar out, so A bar plus A. So what is this law? We call this law as distributive law, right? We call this law as distributive law. So you also need to write down the law because the examiner is asking for that, right? So distributive law. Distributive law. And next, let me use the complement law. So B dot C bar, and this is going to be 1 according to the complement law. Complement law. Right. Then, so now we know that the final answer is going to be equals B dot C bar. B dot C bar, right? B dot C bar. Right now they are asking you to draw the logic circuit only using NOR gates, right? So let me draw that. You need to draw for B dot C bar, right? B dot C bar. So A, let me take A, B and C. So B here. So no gate. Then we have C bar, right? So B dot C bar, right? So you take this C down. And this is going to be, output is going to be Q, right? So this is the logic circuit, right? This is the logic circuit. So if you consider here, right, in this case, a B is coming, and here you are getting B, B, then here you will get B plus B whole thing bar. Then when you simplify using the law, respective law, you will be getting B bar. When you apply the respective law, you will be getting B bar. And here C is coming down. So here C is coming, and B bar plus C again whole thing bar, right? And when you apply the law, you will be getting, when you apply the respective laws, then you will be getting B dot C bar. So we have obtained the answer. So this proves that our logic circuit which we drew is correct, right? And then next question, let's see. The user of the air conditioner says that the switch is not required for the operation of the air conditioner. So do you agree with this statement? Justify your answer. So first of all, do you agree? You must say yes or no. And not only that, also you need to justify your answer. First, you need to say, do you agree? Yes or no, you must write that answer, right? Right? For that also there is marks. And also not only that, then also you need to justify your answer, okay? So we can say here, so what do you think? Yes, right? Yes, because input that represents which is not in the Boolean expression or circuit or solution, right? Input, so in the Boolean input that represents switch A is not in the Boolean expression. See, it's not in the Boolean expression, and also it is not in the circuit or the solution. Input that represent switch, that is A, that is A, is not in the Boolean expression, circuit or solution. Then you can say therefore it is not required for the operation of the air conditioner. Right, okay, done.